Assalamu alaikum. So right now we will discuss the working of microprogram control unit with an example of CPU. But first of all, we need to understand the concept of control unit. Now, control unit is the engine that runs the CPU with the help of control signals. It is responsible to generate control signals so that things happen for CPU and execution happen in sequence. So the signals are generated in the sequence that are specified by the control signals. There are basically two approaches to design control units: the hardware control unit design and microprogram control unit design, but we will discuss microprogram control unit designs. Now, microprogram is a type of control unit with its control value stored as a control word in memory. Microprogram dictates the order in which CPU operations should take place. Now, the horizontal programming, and there is a method that each value is assigned a bit, so it results in faster execution and more faster working of the CPU. This slide shows the architecture of microprogram control unit. The control memory address register specifies the address of microoperations, and the control data register holds the micro instruction read from memory. While the micro operations are being executed, the next address is computed in the next address register circuit and then transferred into the control address register to read the next micro instruction. So this is the state diagram which actually become basis for the generation of control signals. So as you can see in these boxes, there are certain micro operations, and each micro operations is assigned a particular states. So if we count them, the total of them is 9. So there are total 9 states in this example of the CPU that we have taken. And this table shows the total 9 states, and we have assigned address to each states by the mechanism of different logic gates. By assigning address to each state, we will determine that which RTL or register transfer operation is needed in each state. So in this table we will add the different register transfer operations that we need in this CPU in the columns. So whenever a RTL or register transfer occurs at that particular state, then we will assign it number as 1, or if it doesn't, then we will assign it number 0. So after the state is set, we will assign addresses in the columns, the source addresses and the next addresses. And so these addresses are generated either through the mechanism of the sequential address, or we will generate them dynamically through instruction registers. There is a separate mechanism for that, and that actually occurs when there is the process of decode. We actually decode the operation, and then we understand that what operation is needed to be performed. To determine the state transition, we will use the mechanism of multiplexer. The multiplexer will be used as a select bit to determine that what state is which address is needed. If the select bit is 0, the address in the next address field will be generated automatically, but if the select bit is 1, then it will move towards instruction register, and then the instruction will be decoded from instruction register, and then we will determine that what micro instruction should be executed in this particular stage. The select bits are specified in this table. All the select bits are 0 except the stage 3 select bits, and the registers transfer occurring in that state are the decode state, so it will automatically move to the instruction register, and then instruction register will decode that opcode and will tell us that what micro instruction is needed in this particular stage. As you can see in stage 3, the next address field is also not specified. It is due to the fact that the select bit is 1 in this particular stage. So this was our demo for microprogram control unit. Thank you.